Okay, so do you guys know how to graph square root of x and x squared? You feel comfortable with that? Okay, let's do it. So I want to go ahead and graph these on the same graph. And I'm going to focus all this right here in the first quadrant. So graphing square root of x, square root of 0 is 0, square root of 1 is 1, and square root of 4 is 2. We could keep going, but this is good enough for now. Okay, so now we're going to graph g of x. That's just your standard parabola. Again, let's go ahead and in the first quadrant try to make our graph as accurate as possible. 0, 0, 1, 1, and then 2, 4. So this would be my g of x. Okay. So anything you notice about these two graphs, and keep in mind, we're really not going to pay attention to that part of the parabola. Or anything you remember about inverse functions from Algebra 2 or pre-calc. There is a reflection. They're reflected across that line. Anybody know the equation of that line? Y equals x. Okay, let's talk about points. This point on f of x is the point 4, 2. And what did that become if I reflect it across the line y equals x? 2, 4. So in layman's terms, we can say that the x's and the y's switched. And that's really how you probably first learn inverses. You learned about x and y values switching, either in points or also in functions. Okay, you did x equals instead of y equals and so on. And I'm not going to go over everything about these things, but one more thing to kind of note has to do with the slope. Okay, so at this point 4, 2, okay, let's analyze the slope, and then let's do the same thing over here at 2, 4. And they're going to have a relationship. What can you tell me about the slope right here on the f of x, the red graph? Like anything about it?
It's
Positive. And would we say bigger than 1, less than 1? Looks pretty flat, so maybe less than 1. And then over here on g of x, the slope is still positive, so it didn't change signs, but it is now steeper, much steeper, so we'd say that's bigger than 1. Well, I picked two functions that we can derive pretty easily, and so we're going to actually calculate the slopes. So if our f of x was square root of x, remember that's just to the 1/2 power. That derivative is going to be 1/2 x to the negative 1/2. And so the slope at the point 4, 2 is going to be, just plug in a 4 here. And this would be the same thing as this 4 to the negative 1/2 would be like saying square root of 4 in the denominator. So we get 1/4, which lines up with what we said. We said it was positive. We said it was probably less than 1, pretty flat. Anybody want to take a guess as to what the slope's going to be up here? 4? So now we would do g prime of x. And since that was x squared, the derivative would be 2x. And now the x value here is not the same x value. Remember, all the x's and y's are switched. What's the x value at this point that I'm looking at now? 2, right? Not 4. So it's a different x value. And so that would be 2 times 2, which is 4. And what ends up happening is the two slopes are reciprocals. Okay, they're not opposite reciprocals. Remember perpendicular, you had to switch the sign. We're not doing that. Both of these slopes were positive. So it kind of lends itself to this next formula. Now, I have not really proven this to you. I have just given you one example, and we've just looked at one set of slopes. I want to show you something next. You probably don't even want to write this down in your notes, but I just want you to watch, okay? So let's say that I gave you something like this. Y equals f of x. Don't we use y in place of f of x a lot? Yeah. Okay, they mean basically the same thing, right? Okay, if I wanted to take the inverse, I would put an x where the y is, and I would put a y where the x is. So this is now the inverse. And if I wanted to derive this, I would take the derivative with respect to x from both sides. This is implicit differentiation. So derivative of x would be 1. Derivative of f of y. Okay, so that's chain rule. I got to take the derivative of the outside, keep the inside the same, and then go times the derivative of the inside, which would be dy over dx. This is just like when we did implicit differentiation. And if I wanted to get dy over dx by itself, okay, I would just need to divide. So I'm trying to make a connection here between what we're doing now and what you've done previous to this. So if you want to take derivative of an inverse, okay, what that's going to be is 1 over that function's inverse prime of the original function. This is not something you're going to memorize. I just kind of wanted to show you. If you look at this right here, and now let's immediately kind of go in, and I'm going to erase just a little bit here. Let's go in and look at this formula right here. G prime of x equals 1 over f prime of g of x. Today, I don't really want you to worry about memorizing it. That is going to come, because this is not something, you don't get a formula chart on the AP test. Anything you're expected to know, you just have to know. So we're just going to work on applying this formula. Okay, this only works if f and g are inverses. So when we do these problems, there has to be something in the problem that tells you that f and g are inverses. And sometimes they use this word inverse, and sometimes they do something like this. They say f of x is equal to g, and it looks like to the -1 power. Okay? When that happens, that means inverses. So you need to know that. And you have seen that before, hopefully. Okay, so looking at this example, if g of -2 is 5, and f prime of 5 is -1/2, and you're like, what does this mean? Then what is g prime of -2? So if you've already zoned out because you're like, I don't like this, this is hard, I want you to zone back in, because all we're going to do is plug in a formula. G prime of x over here. So what is g prime of -2? It's going to be 1 over, I'm just using the formula here, f prime of g of x. Well, my x in this case is -2. So g of -2. So do they tell us what g of -2 is? Yes, it's 5. And do they tell us what f prime of 5 is? Yeah. It is, yeah, -1/2. So that equals -2. Okay, so like what you have to do is really not that hard on these problems. It's just knowing what to do. Okay, this only works because f and g are inverses. Really, on the AP test, on multiple choice, there's really only going to be one inverse question like this. However, it's going to be probably one of the easiest ones on the test. It's going to look really tough, but if you know how to do it, it's actually super easy. So this 28 is an actual old AP test question. It says, let f be a differentiable function. By the way, what does that mean when they say differentiable? You can take the derivative. That's all it means. It's just part of the problem. Because if we can't take the derivative of f, then I can't really do anything in the problem. So that's in the question stem a lot. And then they give us a lot of information about f. F of 3 is 15, f of 6 is 3, and a couple of f primes. Then they introduce another function, g, also differentiable, and then they give us the relationship. We kind of talked about this a few minutes ago. If they say g of x equals, and it looks like f to the negative 1, what are they telling us is the relationship between f and g? Inverses. So that's kind of the first obstacle here. You have to recognize this is an inverse problem. And then it says, what is g prime of 3? So again, I'm really not going to worry so much about how am I going to remember another formula. I'm just going to use the formula. Okay, right up here, g prime of 3. That's going to be 1 over f prime of g of 3. Now, in the last example, they told us g of 3, everything was great. On this example, they don't tell us g of 3. So can I just use f of 3 and pretend that they're the same? No. Let's just say you did. Let's just say that's not right, but let's say you did write 15 here. What's f prime of 15? They don't tell you, right? So, so that would not be a good move. They are telling us how to find g of 3. You just have to remember about inverses. Okay, see where right up here where it says f of 6 equals 3? If f and g are inverses, then that means that g of 3 equals 6. Look at what I did here. I just switched the x and the y. Okay, so you kind of have to dig a little bit for this information. So g of 3, that's 6. So now the next step is, okay, well, what's f prime of 6? And maybe they give it to us, and maybe we have to search for it. They actually give it to us, though, right here. So my answer is -1/2. So this problem ends up being pretty easy if you understand the relationship between inverses and you know this formula right here. By the way, something like E, this is like the good old not here. This is designed to catch people who don't know what they're doing, and it makes it sound like if you don't know what you're doing, you think, well, maybe it can't be done. That's what I'll guess. This is just not a good thing to guess, ever. Okay, it's kind of a catch-all. I'm not saying it can't be the answer. I'm just saying it isn't usually the answer. Okay, so the next page is actually the homework, but what I would like to do, just because we haven't dealt with tables in a while, is at least get started on this. Okay, so that's it for the lesson. I'm done with the lesson. So on these where you have tables, and the first 6, by the way, have nothing to do with inverse. This is all review stuff. You don't want to plug in the number too early. What happens if you plug the number in and then take the derivative? You're going to get 0 every time. And it's possible that 0 is the answer. But it's not going to be the answer every time. So more times than not, you're going to end up making a mistake. So we want to take the derivative first. So on something like 1, that means product rule. So derivative of f times just plain g plus plain f times derivative of g. And then we can plug the number in. I'm okay with you, instead of rewriting this again, just replacing the 1s right here. Everywhere there's an x, go ahead and put a 1. And now we have to look up the values on the table. So f prime of 1 you want to look in the F prime column in the 1 row, and you want to find the intersection of the 2. So that's going to be a -2. So go ahead and find the other values. And although you don't have to simplify, let's practice it for this because these are most likely going to be multiple choice on the test. Okay, go ahead and check your numbers with mine. Again, you don't have to simplify here, but it's a good practice to do because this is most likely going to be multiple choice. Okay, I want to look at number 5 next. And then you'll get to do the rest on your own. So again, don't plug in 3 too early. Okay, take the derivative. If I'm taking the derivative of g of f of x, that's a chain rule. Remember, that's g prime, leave the inside alone, and then take the derivative of the inside. Notice I'm writing it all out with x's, and then I'm going to go back and I'm going to plug in a 3. And now you can either rewrite it or just erase the x and put a 3. So we need to actually figure out what f of 3 is, and then take g prime of that number. So what is f of 3? 0. So that's 0. So now we got to do g prime of 0, which is 2. And then f prime of 3, which is 1. So your answer here is 2. Okay, the only other thing I'm going to tell you about is some people got confused on number 7 as to what this was really asking you. It says, consider f and g to be inverses. So that's the new thing. It says, fill in the missing info. The only information that's missing is right here. So they're asking you to find g prime of what? Of 1. And you're going to then need to use the table and the formula from the back. So you have a couple of inverse problems. This is an old AP test question. Like